Hello everyone. Today is our last lesson of Unit 5. So go ahead and complete this warm-up on a separate sheet of paper. Remember, you can print this from Canvas or use your own paper to work it out. Pause this video, check for the answer and some notes about how to do it on the next page. Okay, so hopefully you were able to get this done. Question 8, this is just like your check your understanding from last class. So hopefully you can use that as a model. And we will be using a lot of these formulas today. So the first one was just a regular probability problem. And we have our notation with the normal curve, the z-score, table A, and the answer. The next one we have the formulas mu of x bar equals mu that we need today, and sigma of x bar equals sigma over square root n. Remember the 10% condition to check for any time you use the standard deviation. And then also the interpretation is the typical variation from the mean. So that is what we want to say. With letter D, we're using what we found in B and C. And so one interesting thing happens. I got a z-score of 3.88, which, first of all, if I try to draw that on my picture, that's way too high. I can't even put it on there or shade at all. And second of all, on table A, what you'll notice is that you don't get the highest number I think on there is 3.4 or something like that. And so what you do is you just find the highest number you can, and then 3.49 I think, and that's 0.9998. Subtract that from 1, you get 0.002, and just imagine that it's really higher than 0.9998 because they keep going up. So then when you subtract from 1, the real answer would be lower than 0.0002. I do want to show you, though, how we would do this in the calculator. So there is, your homework has gone over this a few times, but there is a way to do normal curve stuff in here if that happens where table A doesn't have all the values. So what you do is second vars 2. Normal CDF. We'll never use PDF. Remember, C stands for cumulative and it has inequalities, which all normal curve problems are. So we'll never use number 1. Second bar is 2. That lower is like a negative infinity. So what you can put for your lower is 3.88, the z-score. And then your upper, since I would be shading to the right because of the greater than sign, I'll just put a bunch of 9s. Just like hit 9 a bunch of times. It's like infinity. There's no infinity button on the calculator. And if we're using z-scores, the mean for a z-score is 0, the standard deviation is 1, and you can hit paste. And then you get an answer in scientific notation. And so 5.22 times 10 to the negative 5 is how we would write that. So I'm going to write this in red on here, and you can feel free to copy it down. Normal CDF. I can get the answer from doing lower 3.88, upper infinity, I just put a bunch of 9s. Mu is 0 and sigma is 1 since we're doing z-scores. And I got 5.22, I think, times 10 to the negative 5. So if we actually turn that into a number, that's going to be 0.1234522. And that is definitely less than 0.002. Either answer is good. So you're fine to continue using table A and getting an answer less than 0.002 and writing it like that. And you're fine to use your calculator and get a more exact answer. Either one works. So check all that out. Hopefully you got it. And if not, just let your teacher know they can help you. Okay, so for our activity today, we have the ACT scores from AK and Providence, our arch nemesis. So we're going to be comparing them. And so to start off, basically just found these values online for at least for the means that made up the standard deviations. And then we have the population data. So I'm going to start off with a little red note here that this is your population values. And then we randomly select 25 students from Ardrey and 30 from Providence, and then we're going to use those two samples to compare and do this worksheet. So in the table, you're doing each sample separately. So I want you to remember the formulas we learned for one sample. I'm going to go ahead and write them down now. They were from we talked about them in the warm-up, where mu of x bar equals mu, sigma of x bar equals sigma over square root n, and then we have an approximately normal shape if the population's already normal, and if the population isn't normal, we should have at least 30 in the sample to be able to use the central limit theorem, which we kind of briefly talked about at the end of last class. So go ahead, and then on number 2, you're using, I just want to add a little extra note to that. Describe the distribution of differences for the sample, for the samples from AKHS and PHS. So I want you to use the samples from number 1 to do number 2 and then number 3. So pause this video, give it a try. Remember our rules from last class and from Unit 4 or Chapter 6 when you're combining distributions that we did the other day as well. All right, so here are our filled-in versions. Remember, we had population values here, and then we had our one sample value or distribution, and so that would be mu of x bar equals mu, sigma of x bar equals sigma over square root n. And then I did check that 10% condition, so make sure you guys see that. Still important to check. All right, and then we had to use the central limit theorems. Even though the population was skewed to the right, the sample size was at least 30 by the central limit theorem. So don't forget about that. Now, number 2, describe the distribution of differences. And so in this case, to get the mean, we just subtracted the means, which we've done that plenty of times. But notation-wise, we're going to write the mean of the difference in sample means is the population mean differences. So mu of x bar 1 minus x bar 2, the mean difference of sample means is equal to the population mean 1 minus population mean 2. And then standard deviation, hopefully you use your rules from combining random variables. Remember we did this last class. Basically, if you look at our 2 classes ago, if we look at what we did, we could square, add, and then square root the whole thing. And so what happens is the squared can be distributed to the top and the bottom. And so what that looks like in a formula is standard deviation of x bar 1 minus x bar 2 equals the square root of standard deviation 1 squared over n1 plus standard deviation 2 squared over n2. So if you think about that, if I distribute this squared to the top and bottom, that's what happens. And so instead of having to do it all separate, we could have just gotten 1.09 by doing, I'll show you in purple, it equals the square root of 3 squared over 25 plus 5 squared over 30. And that's an easier way to get the answer in the future. And then the shape, you have to check both sampling distributions. And so that, don't forget to do that. We need to check normality for both. And in this case, it was okay that one population was normal and the other wasn't because the other had 30 in the sample. So you are allowed to do all that with your sample as long as, in the end, both meet the normal condition separately. So for number 3, we just did a little probability problem that we've been doing lots lately. So don't forget about the notation. We're looking, oops, I erased it. This is what we're looking at for our notation. And that's because we're talking about a random sample of 25 AKHS students, then a random sample of 30. And so this is the difference in the sample means. And then remember, higher mean means that their difference is positive, since we did Ardrey-Kell minus Providence already. For my picture, everything's the same. Got our z-score table A. We do have a z-score formula that we'll be using for these problems that I'll write right here. Z-scores they're equal to value minus mean over standard deviation. The value we'll be interested in here is the difference in the sample means. The mean will be the difference in the population means, and then it'll be over the standard deviation for the sampling distribution. So I just put that symbol there since it comes from here. I don't need to draw that, but that's where it came from. So why don't you guys turn your paper over, copy this down. It should look pretty similar to what we've seen the past couple of days, where we have our mean with the right symbols, standard deviation. We have the sampling without replacement 10% condition that we still have to check, and then the normal condition. And I'm going to fix something on here. Population, so approximately normal when, and I'm just going to cross this off. Hold on, let's see. And you can mix and match. So I'm going to add that note, like we did. In the activity itself. And then there's an official z-score with the official standard deviation plugged in. So I'm going to zoom out so you can get it all in, and then you can pause this video to copy it down, try to check your understanding, and then come back to the video, unpause it to see the answers plus some extra notes about it. Oh, right. So for this check your understanding, should have been pretty straightforward from what the notes had. The shape, they're both normal already, so we checked it that way. The mean formula, standard deviation, check the 10% conditions. Don't forget that, plus the interpretation. But one thing I wanted to show you one more time was on letter D that, again, we got a z-score that I can't even label on my normal curve. And so if I go to my calculator, I can do this in there, second vars 2, and this time it's less than, so I'll start with negative infinity, so negative 99999. You can do the 1e99 that it's defaulted to, negative 1e99 is fine. And the upper would be negative 4.4. And then we keep it 0 and 1 for z-scores, and we get 5.4 times 10 to the negative 6 this time. So again, this time for normal, I'm going to put normal CDF. We have our lower would be negative infinity since I'm doing a less than. Our upper would be the z-score, negative 4.4, mu 0, sigma 1, and I got 5.4 times 10 to the negative 6, I think. And so you can write it like that, or you can put 5 zeros with a 5 after it. I just leave it in scientific notation at that point, which again is definitely less than 0.0002. So either answer is acceptable. Table A answer is limited, but it's totally fine to keep doing it that way. Check Canvas for what to do next. I hope everyone has a great day. Thank you so much.